We find ourselves on the brink of an unprecedented catastrophe of immense magnitude. A mysterious, colossal entity, which some have termed the Purple Goliath, has emerged on the edge of our universe, transmitting unsettling messages across space through the James Webb Space Telescope. Astrophysicists have discovered something profoundly disturbing about this massive body. Brian Cox, a leading expert, provides a grave confirmation. By analyzing intricate data, it appears we are teetering on the edge of witnessing a catastrophic event that could forever alter the night sky. According to recent calculations, the machinery of cosmic observation suggests we are approaching a supernova, a stellar burst of colossal proportions. This extraordinary phenomenon could reshape our understanding of celestial events and forever change the night sky as we know it. To grasp what lies ahead, we must delve into the intricate tapestry of the universe, where stars are born, evolve, and eventually die in spectacular displays. One star, in particular, has captured the attention of astronomers and the public alike. This star, a red giant of immense size and age, resides at the heart of this cosmic turmoil. Its sheer size and complexity have long fascinated scientists. Recent observations of this massive red giant suggest it may be nearing the end of its life cycle. A series of unsettling events indicates that a colossal, life-altering occurrence may soon unfold. This particular star, a red giant in its final stages, has aged over millions of years. It's currently transitioning through the later phase of its life, marked by expansion and cooling, after spending its life converting hydrogen into helium at its core. It's estimated to be around 85 to 88 million years old, making it relatively young by cosmic standards, but ancient in the grander scheme of stellar lifetimes. The star's evolution from a hot blue star to the red giant we see today has been driven by nuclear fusion and gravity. Its current red appearance is due to a cooler surface temperature compared to other stars like our Sun, which boasts a temperature around 5,500 K, while this star's surface registers around 3,500 K. The cooler temperature gives it its distinct red hue, but this color also reveals important insights into its internal state and ongoing cycles. Further enhancing its mysterious allure is its variability. This star, unlike others that follow predictable patterns, unpredictably shifts in brightness. It's classified as a semi-regular variable star, meaning its light undergoes periodic changes. These changes occur in both short, multi-day, and longer 5-year cycles, which have been recorded since the 1800s, as far back as the observations of Sir John Herschel. Ancient cultures like the Romans and Chinese documented this star's changing color, first as yellow, then later as red, over the millennia. These color shifts, combined with its variable brightness, paint a complex picture of a star in flux. In recent years, a significant and alarming event occurred: an extraordinary dimming. In late 2019, this massive red giant began to fade unusually. By February 2020, it had dimmed to such an extent that it was visibly fainter, even to amateur stargazers in light-polluted areas. This sudden drop in brightness was so pronounced that it suggested a dramatic event was taking place. One challenge in understanding this star is the time delay. Due to its distance of around 725 light-years, the light we see now left the star nearly 7 centuries ago. This makes it difficult to predict and fully grasp sudden changes in its behavior. The dimming event serves as a stark reminder of the vastness of space and the limits of our observational capabilities. Cosmologists have taken note of these changes. Andrea Dupree, the head of the Center for Astronomy at Harvard and Smithsonian, led a team in using the Hubble Space Telescope to study the star over 3 years. Their analysis revealed significant insights into the star's dynamic environment. Convection cells on the star's surface heat its outer layers. Observations using Hubble spectra, especially those focused on magnesium lines, show material moving at speeds of about 200,000 miles per hour from the star into its outer atmosphere. The expelled material eventually formed a vast cloud, which led to the star's dimming. Dupree's team found that twice the normal amount of mass was lost from the star's southern hemisphere over just 3 months. This mass loss is significant. While all stars lose mass over time, this star is doing so at a far greater rate than our Sun. The scale of this mass ejection and the resulting dimming has sparked discussions among scientists about whether this event could be a precursor to a massive explosion. As the star continues to behave unpredictably, astronomers are left to grapple with the potential for an impending catastrophic event, one that could redefine the boundaries of our understanding of stellar evolution. Around 725 light-years from Earth, this event adds significant intrigue, as such an impact would be visible from our planet, providing a remarkable opportunity to observe a dazzling phenomenon up close. However, its exact nature remains undetermined. What could this event mean for the future of the universe and its cosmic phenomena? Could it be a sign of a supernova, a catastrophic event marking the dramatic end of a massive star? Supernovae are among the most powerful occurrences in the universe, releasing vast amounts of energy and producing essential elements like oxygen and iron, elements critical for life. If this red supergiant were to undergo a supernova event, it would likely briefly outshine an entire region of the sky, becoming visible across immense distances, possibly even affecting the light reaching Earth. Studying such events not only deepens our understanding of cosmic evolution but also offers insights into the composition and dynamics of the universe. Supernovae play a crucial role in scattering heavy elements created in stars throughout space, shaping future stellar and planetary systems. For astronomers and astrophysicists focusing on stars like this red supergiant, it provides a glimpse into the final stages of a star's life cycle and the catastrophic events that shape galaxies. By observing changes in its brightness, spectral emissions, and mass loss, scientists can refine models of cosmic evolution and better predict the behaviors of similar stars across the universe. Moreover, events like the rare dimming of the star underscore the importance of long-term observational studies and the capabilities of advanced telescopes like the Hubble Space Telescope. These instruments enable researchers to capture detailed data and analyze complex processes occurring millions of light-years away, offering unique insights into the workings of the universe. As our understanding of stars and galaxies continues to advance, each new observation and discovery adds to the tapestry of knowledge about our place in the cosmos. The study of massive phenomena like this red supergiant and its potential supernova event captivates us not only with its grandeur but also broadens our appreciation for the intricate forces governing the universe. While the future behavior of this red supergiant remains uncertain, its recent dramatic dimming serves as a striking reminder of the universe's dynamic and ever-changing nature. By continuing to explore and study such celestial events, scientists are poised to uncover more of the universe's mysteries and expand humanity's understanding of space and our place within it. This dimming event raises questions about the star's future. Could it be a precursor to an impending grandiose explosion, or is it simply a spectacular chapter in the star's long and complex life? Several theories have been proposed to make sense of this extraordinary transformation. One prominent theory suggests it could be part of the star's progression toward a supernova event, as scientists believe it is nearing the end of its life. Another plausible explanation involves dust, possibly shed by the star itself. This material could form a dense cloud capable of blocking the star's light from our perspective. A third theory pertains to changes in the star's photosphere, the outer visible layer, that could be affecting its brightness. Picture this as the precursor to a cosmic disaster of unprecedented scale. Under this vast red giant, CB, on the edge of our observable universe, it is signaling troubling messages through space. Using the James Webb Space Telescope, astronomers have discovered something profoundly unsettling about this massive celestial body. As astrophysicist Brian Cox ominously declares, the swirling data suggests we may be on the brink of witnessing a catastrophic gamma-ray burst that could forever alter the night sky. This extraordinary star has captured the imagination of astronomers and the public alike. This red giant is a colossal body, rich in age and complexity, long a source of fascination. Recent advancements have led to increased interest in this massive entity, raising the possibility of an impending cataclysmic event. In this current scenario, regardless of what these changes might imply, we could be on the verge of witnessing an endless display of breathtaking scale, something far beyond our sun. Imagine a star so immense that if it were to move out of alignment with our sun, its surface would extend beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars. This is not merely an extraordinary exhibition of the star's inherent attributes, but also highlights its stage in the stellar life cycle. As a red giant, it is in the twilight of its existence, characterized by expansion and cooling, following a lifetime spent fusing hydrogen into helium at its core. But what about the age of this supergiant, estimated to be around 88 to 85 million years old? In human terms, it is relatively young, but in terms of stellar lifetimes, it is ancient. It is currently in the red giant stage, a result of millions of years of stellar evolution, marked by significant changes and cycles that have transformed it from a hot blue star to the red giant we observe today. The current instance of stars like this one tells a story of transformation driven by the consistent forces of nuclear fusion and gravity. Its distinctive bronze appearance is yet another sign of its evolved state. The red color is a result of its relatively cooler surface temperature compared to other stars like our Sun. While the Sun's surface temperature is around 5,500 K, this star's cooler surface registers temperatures around 3,500 K. This cooler temperature gives the star its red hue. However, this color is not merely visual. It provides clues about the star's condition and the cycles occurring inside, adding to its identity. What further defines its character is its variable nature. This star, classified as a semi-regular variable, occasionally fluctuates in brightness. This variability is a dramatic dance of light that has captivated astronomers throughout history. Ancient Roman and Chinese texts indicate that around 1,000 years ago, the star appeared yellow. By the 900s, Arabic astronomers had described it as red. This shift in color over human history is not just a detail in the annals of cosmology, but also a reflection of the star's immense transformation. The variable brightness of the star offers another fascinating aspect. It is a semi-regular variable star, meaning its light occasionally fluctuates. This variability is a dramatic dance of brightness that has captivated astronomers throughout history. Ancient Roman and Chinese texts indicate that around 1,000 years ago, the star appeared yellow. By the 900s, Arabic astronomers had described it as red. This shift in color over human history is not just a detail in the annals of cosmology, but also a reflection of the star's immense transformation. Stargazers and skywatchers have been observing a star for centuries, noting its multi-day cycle alongside a longer cycle that spans around 5 years. These cycles have been recorded as far back as 1836 by Sir John Herschel, and possibly even earlier through local oral traditions. What makes this star unique isn't just its changing brightness, but its unusual behavior. Unlike many stars that follow predictable patterns, this one erratically deviates from its normal fading and brightening, suggesting less understood and conflicting processes occurring within its structure. Recent discoveries have captured the attention of astronomers and sky watchers alike, particularly with a striking change in its appearance. One significant event, known as the exceptional dimming, occurred in late 2019, when the red giant, one of the most prominent stars in the night sky, began to mysteriously fade. Its brightness dropped dramatically to such an extent that it started losing its shine at a rapid rate, reaching its lowest brilliance in February 2020. Normally visible even in light-polluted areas, the star became noticeably fainter, an observable change even to amateur observers. However, there is one challenge in trying to unravel this star's events: the oddity of it. When we observe a star like this, we're not seeing it as it exists today but as it was in the past, due to the time it takes for light to travel to us. In this star's case, at around 725 light-years away, the light we see now left the star nearly 700 years ago. This delay makes it difficult to predict and make sense of sudden changes in a star's behavior, as we are essentially peering into its past. The extraordinary dimming event served as a clear illustration of the natural complexities of astronomical observations and the limitations of our understanding, while managing vast, infinite scales and the temporal quirks they present. Andrea Dupree, head of the Center for Astrophysics at Harvard and Smithsonian, and her team utilized the Hubble Space Telescope to study the star as part of a 3-year investigation. Their goal was to examine variations in its outer environment. These observations provided incredible insights into the dynamic nature of variable stars like this one, which routinely expand and contract, causing fluctuations in brightness. Hubble's sensitivity to light allowed the researchers to examine the layers above the star's surface, which were primarily heated by the star's turbulent convection cells. Further analysis of Hubble's spectra, taken at different times during 2019 and 2020, revealed the movement of material in the star's outer environment, particularly focusing on magnesium lines, indicative of cosmic conditions. These observations showed material moving at speeds of around 200,000 miles per hour from the star's surface into its outer environment. This hot, dense material eventually expanded thousands of miles away from the star, forming a cloud that caused the star's dimming. Dupree and her team estimated that twice the usual amount of material was lost from the star's southern hemisphere over the course of 3 months due to this emission. This mass loss was significant, especially since, like all stars, this one routinely loses mass, but at a much higher rate than our Sun. The scale of this mass ejection and the subsequent dimming sparked discussions among astronomers about whether this event could be a precursor to a supernova. Given the star's location, around 725 light-years from Earth, a supernova in this region could potentially be visible from Earth and offer an extraordinary opportunity to observe such a dramatic event up close. However, this has yet to be convincingly confirmed. What does this event mean for our understanding of the universe and its cosmic phenomena? Could it be a sign of an impending supernova, a catastrophic event marking the explosive death of a massive star? Supernovae are among the most powerful occurrences in the universe, releasing immense amounts of energy and dispersing heavy elements vital for life, like oxygen and iron. If this red giant were to undergo a supernova, it would likely briefly outshine an entire galaxy, visible even during daylight on Earth. Studying such events not only deepens our understanding of stellar evolution but also provides insights into the composition and dynamics of the universe. Supernovae are crucial for dispersing heavy elements formed in stars throughout space, enriching future generations of stars and planetary systems. Observing stars like this red giant offers a glimpse into the later stages of stellar life cycles and the catastrophic events that shape galaxies. By noting changes in its brightness, spectral emissions, and mass loss, scientists can refine models of stellar evolution and better predict the behavior of similar stars in the universe. Events like the dramatic dimming of this star highlight the importance of long-term observational studies and the capabilities of advanced telescopes like the Hubble Space Telescope. These tools enable researchers to gather detailed data and investigate complex processes happening millions of light-years away, offering remarkable insights into the workings of the universe. As our understanding of stars and galaxies continues to evolve, each new observation and discovery adds to the tapestry of knowledge about our place in the cosmos. While the future behavior of this red giant remains uncertain, its recent extraordinary dimming serves as a strong reminder of the dynamic and ever-changing nature of the universe. By continuing to investigate and study such celestial events, researchers hope to uncover more of the universe's mysteries and expand humanity's understanding of the cosmos. This dimming event stands as a solid indication of the natural processes at work and presents both challenges and opportunities for astronomers in exploring the vast unknowns of space. Is this a sign of an approaching supernova, or simply an extraordinary event in the star's long and complex life? Several theories have been proposed to make sense of this astonishing change. One prominent hypothesis suggests a phase in the supernova process, a theory stemming from the belief that the star is nearing the end of its life. Another plausible explanation involves dust, possibly from the star itself. Like other red supergiants, this one sheds material, and it is thought that this material could form a build-up cloud dense enough to block the star's light from our perspective. A third theory concerns changes in the star's photosphere, the visible outer layer, which could impact its brightness.